Today I'll be building this frosted ice blue mechanical keyboard kit from SM Keyboards. It features a laser cut acrylic case designed for the Quefrency PVC from Kebio. It has 7 main layers as well as extra layers for the stands. The top half is frosted blue and the bottom half is opal. The plate is made of white palm. This will be my first mechanical keyboard with a split layout, so I'm super excited to jump right into it. I ordered this kit from SM Keyboards in stock inventory, and it came with the PCB as well as a microfiber cloth and sticker, rubber feet, extra hardware, and a hex tool. To start, I grabbed my rose pink silicone Workmat from American Haptics. It helps me stay organized while working, but it's also important to protect your PCB with an anti-static mat. I really love this one because it's very large and has compartments at the top. I also went ahead and grabbed my keycap set. For this build, I am using the IFK Comfy Keyset sent to me by the Krytox company. It's designed by Ghost Girl and manufactured by Infinikey. These are MX-compatible keycaps made of PBT with dye sublimation for the legends. It features a cherry profile and includes UK ISO keys. This set supports many keyboard layout varieties, including ortho and split keyboards, like this one. It has a lot of novelty keys and color variations as well. The PCB for this board is the Rev 2, which requires soldering. It's a 60 to 65% split staggered keyboard with a 2x5 macro section option on the left side of the board. It also has the option to add a rotary knob to the top right or top left corners if you'd like. The two halves connect via a 3.5mm TRRS cable. It's important to test the PCB prior to building the keyboard to make sure everything works correctly. I plugged the left half of the PCB to my MacBook with a USB-C cable, then connected this half to the right side of the PCB with a TRRS cable. VIA will automatically detect that it's connected, and it recognized the Rev 2 for me right away. I used my pink pointed tweezers from Stationery Stash to test the PCB. I touched the tips of the tweezers to the 2 pads for each individual switch and made sure each key lit up on VIA. After testing everything out, the PCB was found to be in good working order. Before I begin the assembly process, I will need to break off the macro pad area on the left side of the PCB since this case does not support the macro pad. It's a little scary to do since the PCB is quite strong, but there are no special tools or methods required, and you can just use your hands to break it off. Next, I used the included hex tool to remove the screws on the case so that I could access the plate. I'll need the plate to help me position the switches and help me visualize how the keyboard layout will look. For switches, I am going with Alpaca linear switches gifted to me from NomKeys.xyz. I usually lube and fill my own switches, but with having a busy schedule nearly every day, it's often hard for me to find the time to do it. NomKeys came to save the day by providing me with the service of lubing and filming these switches for me. Up until this point, I really wasn't sure how I wanted to arrange the switch placement, so I took the next few moments arranging my switches and keycaps to get a better idea on how it will end up. For the stabilizers, I went with Durock V2 transparent screw-in stabs. I only needed the 4 2-unit wires for this build. For lube, I went with Krytox 205G0 in my Kinetic Labs palette and applied it to the housings and sliders with a 000 brush. I will be lubing the wires with a syringe after the stabs are installed on the board, so I inserted the wires into the housings without any modifications for now. The next step will be to install the stabs onto the PCB. I used a screwdriver from my iFixit kit to attach them via screws. It's important to note that the bottom row of the PCB requires the stab wire to be orientated above the switch, while the rest of the board can support the wire flip the other direction. After the stabs are in place, the next step is to lube the wires with the Krytox company stabilizer grease syringe kit. This method is so much easier to do, and it allows you to perfectly apply and adjust the grease for better sound and to eliminate wire rattle by filling the void in the stem where the wire resides. I used a stem holder to move the slider up and down while applying it, helping the grease spread around a little. Now that the stabs are on, it's time to solder the switches. Remember to wear proper protective eyewear and a respirator to keep yourself safe from the fumes. I soldered in the switches a few at a time, row by row. Unfortunately, after filming the soldering portion, I wasn't happy with how the plate was sitting with the switches, so I ended up having to desolder some of them in order to adjust the plate. This led to a few mistakes which will require some more fixes. I decided to go ahead and finish the build anyway so that I could see the final board. But don't worry, the fix is in progress, so this board will be 100% complete soon. In the meantime, it's important to test your switches after soldering before putting it into your keyboard case. Plug in the PCB and go to the Key Tester tab in VIA. Press each switch and let the app register each key press. If a key isn't working, unplug the PCB and check your solder work. You may have to desolder and redo it. If you find that it could be a faulty switch, remove it and replace it. The PCB with switches is ready to go. I'll now be using the hex tool again to disassemble the case and add the plate back in. I also went ahead and added the rubber feet that came with the kit to the bottom of the case. Now that everything is good to go, it's time to finally add the keycap set. I enjoyed choosing the novelty keys I wanted for the right column and the light blue keys for the top two corners and the enter key. The keyboard is now ready to be plugged in for the first time as a fully assembled keyboard. I first plugged in my TRRS cable into the two halves, then plugged in my coiled cable from Personal Loot to power it. Right away, I noticed a subtle RGB backlight under the PCB that you could see within the layers of acrylic. I like the default settings for the RGB, but I definitely recommend playing with the light settings in VIA for different effects. Overall, I'm really happy with how this split keyboard build turned out. I can't wait to fix up the PCB, but in the meantime, I enjoyed taking some photos of the finished result. I'm quite happy with how the keycap set matches the color of the keyboard case, and the Alpaca switches feel super smooth. I also added the keycap set to my KBD Pad Mark II to match. As you can see, this is the first YouTube video for my new channel. I plan to share more keyboard builds soon, as well as keyboard mods, so be sure to like and subscribe for more. Thanks for watching!